All right, we're given an equation in what's called standard form. It's when the x and the y are both on the same side of the equal sign, and we're asked to find its x and y intercept. Now, sort of think about here is the x and y intercept. The y-intercept is the place where it crosses the y-axis, and if you go to plot any point on the y-axis, then its x-coordinate is always 0, because starting from the origin to go somewhere, anywhere on the y-axis, you don't have to go left, right at all. There's x-coordinate is nothing. There's no movement. So it's just straight up or straight down. So we have a y-coordinate, but we don't have an x. Well, we have an x-coordinate, but it's 0. And for the x-axis, if we're crossing the x-axis, it's kind of a similar thing. We travel, out to our x-coordinate, but there's no up-down movement after that to locate that point. So it's just straight out on the x-axis or straight left, whatever. But the y-coordinate is 0 because it's not, the amount it's above or below the x-axis is nothing, right? So your points for the axes, for the intercepts, always have 0 in them. So it's x equals 0 for the y-intercept and y equals 0 for the x-intercept. And I can always think of this as because on the y-intercept, y has a non-zero value. On the x-intercept, then x has a non-zero value. So the one that's not non-zero is 0. And the way to find it is pretty straightforward. Since our equation is it's a statement that's true about every point that's on the line. So it'll be true about these as well. And so if I want to find the y-intercept, all I do is I say, well, the y-intercept is where x is 0. So I'm just going to replace x with 0, right? And then that whole term just goes away, and I solve for y, and I get y equals 5, which means that the point 0, 5 is on that line. So this is 0, 5. I go over here to the x-intercept. Well, if I want to find the x-intercept, x is going to have some non-zero value, and y is going to be 0. So it's going to be 5x plus 2 times 0. And then that term goes away, and I solve for x, and I get 2, right? So the point 2, 0 is on that line. So this over here, 2, 0. That's how we find intercepts by hand. So I guess we're not letting the machine do the work for us. Okay? So again, if you want to find the y-intercept, you substitute 0 for x. If you want to find the x-intercept, you substitute 0 for y. And usually the way that I remember that is I remember that on the y-intercept, the y-coordinate has a non-zero value. On the x-intercept, the x-coordinate has some sort of non-zero value. Most of the time, of course, it is possible, I suppose, for the line to pass right through the origin, like one of our direct variation equations, and then the x and y-intercept are both 0, 0.